Hello and welcome to a tutorial on ofxCv, and I will be showing you a tutorial on displaying a difference between pixels from a live input and display them on the screen. So what I've been using is Carl McDonald's ofxCv library, which is an additional add-on to the standard OpenCV library that OpenFrameworks already has. And the particular one which I am looking at and will be talking through is example difference, would be this particular one. So to start off, you'll need to open the simple project generator, which if we start, we go to add-ons, OpenCV and ofxCv as well, which is the one which is added. Then we'll go here, we'll just do ofxCv tutorial difference, let's call it. And then we'll just generate the project. And whilst we wait for that to generate, I'll be this tutorial will be explaining how to go through it pretty much line by line. So once you've generated it, you go into your apps, find it, and open the project file. Get rid of the side. Now what we can notice is that in our add-ons folder we have both these folders which are needed for the particular add-on, for the particular tutorial. So if we go into the ofApp, we won't need any of these functions. And we'll also need to start off by including ofxCv.h. So we'll get all of the functions and all of the variables needed. So to start off with, we've got our setup, update, and draw, which we'll be using, and we will be needing 4 variables for this particular tutorial. We will need OF video grabber. We will need OF pixels, which we'll call previous, OF image, which we'll call diff, and we'll get something from the CV standard library, which is a scalar, and we'll call it diff mean. So what OF video grabber does is that it gets live video input, and it will do exactly what it says. It will grab it, and you'll be able to display it on a screen. OF pixels is pretty much a pixel array. That's pretty much what it is. It's same as processing's pixel array when you have a P image or your capture. And OF image is pretty much a P image in a processing way in OpenFrameworks, which I'm sure quite a few of you have used. And this one's just going to be capturing an image of the difference between the camera frame and the previous frame of the camera. And what a scalar is, it's pretty much a 4-dimensional vector. So where in a normal vector, where basically you would have x, y, z, and a, it's pretty much the same as that, but you typically would use it for color information and the way you access it. Instead of saying diff mean.x, you access it by saying diff mean 0, 1, 2, and 3 to access those channels. So now we've got all of our variables. We'll be moving into the ofApp, which we will get rid of a load of unnecessary functions, because we only be needing these 3. So to start off with, we will be using some shorthand, because we'll be using a lot of the ofxCv library and a lot of the CV library as well. So we'll be using namespace ofxCv, and this will just allow us to not write these words a lot. For example, we will do something like ofx CV : or we would just do CV : oops, don't know what I just did there. Let's unfold all these, which is pretty much what we did in the of_app.h, which we did right here. We wouldn't want to be doing that all over our code. So to start off with, we would want to set vertical sync to true, and we would want to set up the camera size as well. So we want width and height, and our particular width is going to be 320 by 240. So height, width. We want then to do imitate, and from what this shows us is that we're going to be needing a mirror, an original, and then an int mirror CV image type. So what that basically means is that we would need we need two inputs, and then we need an output, I think. Or maybe this is particularly wrong with how it's actually shown. We actually only need two. Thinking about it, we don't need all three. So what imitate does is that it will take the settings of the original and it will mirror them into the first parameter, which is going to be previous, which is our pixel array. So our pixel object is going to copy the same setup values as cam. So it's going to be 320 by 240. And we're going to do the same for diff and cam, because when you're comparing two different things, to two different objects, you want them to be the same size, so when you go through all the pixels, you don't get an array out of bounds error, or any null pointers, or anything like that at all. And that's all we need to do in the setup. So in update, we want to update the camera. We want to get a brand new frame for the camera. And then once we've done that, we want to check if it's a new frame, so we're not continuously checking the same particular frame. Our next function that we're going to be looking into is absdiff. Now what absdiff is that it finds the absolute difference between our first two parameters. So we've got our previous pixel object, which is the previous frame of the camera object, and we got the camera object, which is the current frame. So we're just comparing between the two different pixels, the pixel selections of these two objects, and then it's going to be outputted into diff. So we're just going to check that, and it will be put into the image. And if you're worried that it's going to be a negative number, don't be, because what ABS is that it's absolute, meaning that you're going to have no negative numbers. The range is 0 to infinity. That's what the range is. It's never going to go into minuses. So once we've done that, we want to update our image, similar to processing, where you would want to update your pixel array, or update your pixels, so then any changes you've done to them can actually be displayed. This is pretty much the same case with open frameworks. You want to do diff.update to update your pixels, otherwise you will not see them. Once we've done that, we want to copy the camera pixel array into our previous, because we've already done our comparison, so we need for the next loop we need to copy it, copy the current frame, So then when the camera updates again, we'll be able to compare those two frames. And then we want to be getting our scalar, and we'll be using this slightly complex function, which is a slightly complex line of code. So mean returns a scalar value, which is what diff mean is. And just to remind you what a scalar value is, it's pretty much like a four-dimensional vector, where not a four-dimensional vector. It's pretty much a vector that has four directions. You got your x, y, z, and a. But it's used for color information, and the way you access it is by using indexing. So 0 for the first element, 1 for the second, 2 for the third, and 3 for the last element. So that's why it returns. But what mean actually takes in is a CV object called a mat object. Now, what a mat object is OpenCV uses this all over the place, and it's a pretty handy way of transferring information and storing it as well, because it's an OpenCV class which is pretty much a dense array, a complex data structure. So it's sort of like a matrix of some sort, and we put that in, and we put that into it, but we currently don't have a mat object. So what we have to do is that we have to convert our of image, the difference, into a mat object. And the way you do that is that you put in the image to the toCV function, and that will return a mat object, which will then be inputted into the mean function. And now we'll just find the mean of all the different color values that are within the image. But because this mean is pretty small, we want to actually just buff it up a bit by a scalar of 50. And pretty much what this does is that if you had something like this, it's pretty much doing the same as this, so then you would just have 50, 50, oops, 50, 50. And that's pretty much what it'll do. You don't have to worry about too much there. Nothing too scary about that. So we've done all our update stuff. We just need a drawer tool now. So what we need to do is that we do offset color, and we set it to 255. Just get rid of all this lot. And we want to draw our camera as well. And we want to draw it to 0, 0, and we want to draw out diff as well, because that's a P image, that's an OF image, as we recall. Now, let's see what happens if we run this. And it will take a little while to compile, and it'll take a little bit longer for me because as I'm recording. So, yeah, that will take its time to compile. But what we also want to do, once we've checked this, is that we would also want to display the color values which are being differed between the two frames. So whether there's a lot of red, a lot of green being changed, a lot of blue being changed, we want to actually display that in some sort of bar graph. So we'll do that once it has compiled, and that will pretty much be the tutorial on how to do that. But this bit of the code is pretty much the core part, the main functionality of it. And it's going to take a little longer. Linking, should get there now. Succeeded. So now we're just going to open up this, And there we are. So now, as I move, you can see that on this side that it's actually showing the differences between the frames. If I stay still, it will turn black. But if I move, then it will actually show all the different colors which are actually changing. And I don't know what's actually behind it. But you'll probably be able to see a little bit of my jumper or whatever is behind me. So if we stop that. Now we want to actually display the different bars. And the way that we will do that is that we'll just get all the different diff red is equal to diff mean, and we want 0 for that one. And we could just copy this. So we've got diff red, we want diff green, as well as diff blue. And we just want to do earth set color, and we want 255 0 0. Oh, did a bit too many there. And we just want to set these down, change this one to green. Let's do that, and then change the next one to blue. And we just do OF draw rectangle, and we just do 0 0 0 diff red, and the height is say 10. And we want the same here, and the same here. But this is going to be diff green, and this is going to be diff blue. And we just want to move these down. I know, let's say 15, and then we'll call this 30. We run that. Hopefully there should be no errors in this, and it shouldn't take all too long to compile. There we are. It's just done the ones. There we are. So now we are showing this, and you can see the different colors, and you can see how crazy it's getting the more that I move, and you can clearly see that the colors are changing quite rapidly. Like there's a lot of red moving. Like if I move my jumper a bit more, maybe a bit more blue is showing. I don't know how to make green show a bit more. Like if I do this, it's only red. So that's what that's showing. So yeah, that is pretty much how to use OpenCV to compare the previous frame of pixels to the current frame of pixels and display that with an image, as well as by displaying it from different colors in a bar chart, a live bar chart of some sort. I hope this has been useful, and I'll see you at some other point.